Welcome to The Explainer. Today, we're tackling a fundamental crossroad in data analysis. If you've ever just sat there, staring at a data set in SPSS, needing to compare two groups, but totally second-guessing your approach based on how your data looks, well, you're absolutely in the right place. We're going to break down the exact paths you need to take to unlock the answers hidden in that data.
Just imagine you're all geared up to run your analysis. You've got your two groups perfectly set up, but then, boom, you realize your data isn't perfectly shaped. It's skewed, it's messy, it's basically breaking all the rules. So how do you compare two groups when your data completely refuses to play nice with standard assumptions? It's a very real-world data problem. Do you just throw your hands up and quit? Absolutely not. You just need to know how to read the map.
Okay, let's dive into this outline. First up, we'll hit the normality fork. Then we'll look at the two independent sample test, followed by the distribution-free alternative. After that, we'll unpack the Mann-Whitney U-test, and finally, we'll wrap up by actually running Mann-Whitney in SPSS.
All right, Section 1, the normality fork.
So here is the absolute golden rule. You must first check the normality of the variable. This right here is the critical moment you reach that fork in the road. Does your data actually follow a nice, neat, normal bell curve, or doesn't it? If it's heavily skewed, simply comparing averages is going to give you totally misleading results. The answer to this one question literally dictates every single step that follows.
Moving on to Section 2, two independent sample tests.
Whenever we run this standard test, we have to set up competing hypotheses. The null hypothesis states that the two population means are totally equal, while the alternative hypothesis claims, well, that they are not equal. Now notice we are specifically looking at the means here. That's a really important distinction because comparing means is only mathematically sound if we've already confirmed that our data is beautifully and normally distributed.
So how do we actually tell SPSS to do this? It's a really quick 4-step sprint. Step 1, you just head up to the Analyzed menu and find Compare Means. Step 2, from that drop-down, select Independent Sample Test. Step 3, when the dialog box pops up, select your test variable and pop in your grouping variable. And Step 4, just click OK. Just like that, you've successfully navigated the standard parametric path. Easy, right?
But what if things get messy? That brings us to Section 3, the distribution-free alternative.
Now, what's really interesting about this concept is that when we talk about non-parametric tests, we're talking about statistical tests that do not make assumptions about the distribution of your data. Unlike those strict parametric tests, these are completely distribution-free. Think of them as your rugged off-road vehicle for when the smooth paved highway of normality is closed off. They totally save the day when those strict assumptions just can't be met.
Which leads us perfectly into Section 4, the Mann-Whitney U-test.
The Mann-Whitney U-test is the specific tool used to compare two independent groups when we have to go off-road. The absolute crucial takeaway here is that it acts as the direct, distribution-free alternate to the independent sample t-test we just talked about. It accomplishes the exact same overarching goal, comparing those groups, but without demanding that your data be perfectly normal. It's a real lifesaver.
Let's take a look at the hypotheses for the Mann-Whitney U-test. The null hypothesis states that the two populations are equal, and the alternative hypothesis states they are not equal. Do you see this subtle but brilliant repetition of structure here? It looks incredibly similar to our parametric test, but with one massive key difference. We are talking about the populations being equal, not specifically the population means. Because we aren't assuming a normal distribution, we kind of step back and compare the overall populations instead of zeroing in on the average. But the core logic? It remains completely identical.
All right, let's get practical. Section 5, running Mann-Whitney in SPSS.
To actually execute this test, you're going to navigate right back to that familiar Analyze menu. But this time, we are bypassing Compare Means altogether and going straight down to non-parametric tests. From there, you choose Legacy Dialogs and finally select two independent samples. So you literally never get lost in the interface. It's just Analyze, non-parametric, Legacy, and then two independent samples.
And this brilliantly illustrates what happens next. Once that dialog box opens up, you have two main fields to populate. Your grouping variable box takes the exact variable that defines the groups you're trying to compare. Right below that, the test variable list is where you drop the actual variable you want to analyze. It's super straightforward. Grouping goes to grouping, test variable goes to test.
We are literally at the finish line now. Under the test type section, just make absolutely sure you check the box for the Mann-Whitney U test. If you happen to need to adjust your confidence intervals, you can click Options, specify your desired level, and hit Continue. Once the whole shebang is set up, simply click OK. And that's it. SPSS is going to do all the heavy lifting from there, completely free from the constraints of normal distribution assumptions.
And that brings us to the end of our journey on the explainer today. We've cruised down the standard parametric highway, and we've successfully navigated the non-parametric off-route alternative. We've seen exactly how to drive SPSS to get the precise results you need, regardless of how messy the shape of your data is. So, I want to leave you with this question to ponder as you crack open your own datasets. Will you just blindly trust the normal distribution next time you sit down to analyze? Or are you finally ready to take control, check those variables, and confidently go distribution-free when the data demands it? Thank you so much for joining me today.